All right, so we're starting off today with more on slopes, 2.4. All right. All right, so the first thing we're talking about in this section are parallel lines. They are lines that do not touch or cross, and that means they will have the same incline, or in other words, the same slope. All right, and Miss Lassiter, yes, I need to make that adjustment. So I'll do that sometime today. Yep, no problem, no problem. All right, perpendicular lines. All right, so perpendicular lines, they intersect at a 90-degree angle, and the slopes are negative reciprocals. All right, so we'll talk about that in a second. And remember that red square in there lets you know that we have a negative reciprocal. I mean, let us know that we have a 90-degree angle. All right. So let's make sure we're okay with what that means. All right, so if we're just talking about reciprocals, reciprocals are just flipping your fraction. So if I have 3/4, then the reciprocal of 3/4 would be 4/3. And I have an arrow going back and forth because, of course, the reciprocal of 4/3 would be 3/4. Negative 10 over 7, then the reciprocal would be negative 7 over 10. Then the reciprocal of 5 is 1 over 5. So if we're just talking about reciprocals, all we're doing are flipping. All we're doing is flipping our fraction. But what we need is a negative reciprocal. So negative in mathematics means opposite. So if I have 3/4, if I want the negative reciprocal, not only will I flip the fraction, but I also will use the opposite sign. So the negative reciprocal is flipping the fraction and using the opposite sign. So if I had negative 10 over 7, the negative reciprocal would be positive 7 over 10. And then 5, the negative reciprocal would be negative 1 over 5. Questions? So for perpendicular lines, we need negative reciprocals. All right, so just making sure we're okay with the concept of having a slope of a line or a line that's parallel to another line and perpendicular to another line, and what the slopes would have to be if they're parallel or if they're perpendicular. So if my original slope is 8 over 3, and I want a line that's parallel to that, the slope would have to be 8 over 3. So parallel lines, the slope is going to be the same. Now, if I want a slope that's perpendicular to it, I will use the opposite sign, so it was positive, and then I will flip the fraction. And so that'll be a negative 3/8. All right. Questions, questions, questions. For the next one, if my original slope is negative 9 over 11, a slope that's parallel to that would be negative 9 over 11. And then a slope that's perpendicular to that, or the slope of a line that's perpendicular to that, would be a positive 11 over 9. All right. Questions? Any questions before we look at an example? Oh, see somebody in the chat. Sorry. How's it parallel? Going back to our original definition of parallel lines, they have to be, the slopes have to be the same. So if you want a line that's parallel to this original line right here, the slope has to be the same. And then if you want it to be perpendicular, it would be the opposite sign and you flip the fraction. All right. Hopefully that answered your question. All right, so write the equation of the line passing, left off G, passing through -3, 1, and parallel to the line y equal to 2x plus 1. All right. First, we have to establish what the slope will be of a line parallel to the equation that we have. So we have y equal to 2x plus 1. The slope of this line is 2. All right, so that comes from what's sitting in front of your x whenever your equation is in slope-intercept form. In other words, y solve that linear equation has y by itself on one side of your equation. Whatever's sitting in front of x is your slope. So this is our original slope. So a line that's parallel to that would be the same. All right. So before we go any further, make sure we're all right. We want a line that's parallel to the one that we have. All right. So now we have our slope, which is 2, and our point, x1, y1, which is -3, 1. We can use the point slope formula. Y minus y1 equal to m times x minus x1. Y1 is 1, m is 2, x1 is 3. Don't forget negative and negative turns positive. So when I distribute this 2, that'll be 2x plus 6. Then add 1 to both sides. Y is equal to 2x plus 7. All right, questions? All right, let's do another one. All right, write an equation of the line passing through 3, -5, and is perpendicular to x plus 4y minus 8 equal to 0. And they want us to write in general form. And so we'll talk about that form in a second, but let's go ahead and start the process. First thing we'll do is take the equation that we have and figure out what the slope is. So we need to solve for y. So I'll subtract x and add 8 to both sides. That'll leave me with 4y equal to -x plus 8. Divide both sides by 4. These 4's cancel. And this 4, don't forget, has to be distributed to each term in the numerator. So y is equal to -x over 4. And I have to write that out. Plus 8 over 4. So that's our most simplified equation. All right, so don't forget, the reason why we do this is because we want to know what our slope is. Once it's in this form, in other words, we solve the equation for y, what's sitting in front of x is my slope. So m is equal to -1/4. So that's the original slope that the equation, that the problem has given us. Now we want a slope that's perpendicular, or a line that's perpendicular to this line. So that means the slope has to be a negative reciprocal. That's going to be a positive 4 over 1, which is just positive 4. So that's a slope that's perpendicular. Slope of a line is perpendicular. All right, so before we go any further, questions? All right. So we have our slope. Our slope is 4. And our point is 3, -5. I'll come down some. All right, so there's a formula. Y minus y1 equal to m times x minus x1. So it's y minus -5 equal to 4 times x minus 3. So that's y plus 5. Negative to negative is positive. Distribute the 4. That's 4x minus 12. Subtract 5. y is equal to 4x minus 17. So before we finish off the problem, questions. All right. So don't forget they ask for a general form. That is just ax plus by plus c equals 0. So basically all of your terms are one side. And we just set one side equal to 0. Say it like that. Set one side equal to 0. So if I have y equal to 4x minus 17, I'll subtract y from both sides. Y is canceled on the left. So I have 0 equal to 4x minus y minus 17. And that will be my answer in general form. Questions, questions, questions. All right. Questions on those type of problems. Those are the only two types of problems that are in the section. Questions on anything before we leave it? I want to call them parent functions. Okay, call it parent. So here in 2.5, we're looking at transformation of functions. So we're going to start off with our basic or parent functions. All right, so we have our 6 basic parent functions that we will be looking at or using. We have y equal to x, just our linear equation. Then we have our parabola, quadratic equation, x squared. We have our cubic equation, y equal to x cubed, square root. Square root of x gives us this next shape or next graph. Then we have the cube root of x. Then we have the absolute value of x. Okay, so when it comes to this section, these are your parent functions, and you will have transformations that will occur that will cause your parent function to shift or stretch or shrink. And so your assignment in this section, I normally give an extra assignment if we're in class. I won't do that. Just that all you would do is just do your My Math Lab homework. So basically, what I mean is that you have y equal to x squared as your parent function, but then you will get y equal to x plus 1 squared, or y equal to x squared plus 1. And so the 1 being inside of the square versus being outside of the square is going to cause it to shift up, down, right, or left. Just like if you were to have x squared minus 1, I'll do it the same way. X minus 1 squared versus x squared minus 1. So that minus sign is going to do something different versus the plus sign. But so that would be what you would do for this section of this assignment. Look at 2.5. If you have questions, feel free to ask. But a lot of times I like to let you guys analyze that. And it's pretty much self-explanatory once you get in there and start actually doing it. Like I said, what I normally would do is give an assignment that would emphasize those transformations. But since we're not face-to-face, we'll just do the My Math Lab work. And when you go in there, and if you're having questions on the differences between, that, then just let me know and we can talk about it. But I don't take up a full lecture doing that because, it's just graphing. And, for the most part, most of us throw it in the graphing calculator. At this moment, we're not learning about graphing. So questions as far as 2.5 and what we're doing with that. All right. So let's start 2.6.
Hey, sir, real quick.
Yep.
So might be a weird question, but are we supposed to know how to do this all on the graphing calculator at this point?
Either know how to use a graphing calculator or a graphing tool.
Yep.
Whether it be something, just on Google. I mean, not Google, but on the internet, Google graphing tool, graphing calculator, they're free things like that. If you have any issues or questions about using your graphing calculator or using a graphing tool on the internet, you always feel free to let me know. We can talk about it.
Okay.
That's something that I normally address individually because everybody's calculator may be different,
Okay.
So, yep,
All right.
yep.
I appreciate it. Thank you.
Not a problem, not a problem. So just harping back on what he just asked, always feel free to email me. And if we have to set up another Zoom session or something individually, we can do that for anything. But, whether it's calculator work or, any of these problems that we're talking about, my door is always open. And all we got to do is set it up and then we can, make it happen from there. All right. So like I said, I don't plan on finishing this, but at least want to go ahead and start it. All right, so we're looking at combination of functions and composite functions. First thing we're going with is finding the domain. All right, so find the domain is the first thing that they start us off with in this section. So what we're doing is we're looking for all the values that can be used for x. And another way of looking at that is all values that can be plugged into the equation. So to find the values that can be used, what we can do is look for the values that cannot be used. Oftentimes, the values that cannot be used is a smaller sample or a smaller set than the numbers that can be used. And so you'll see what I mean as we get into that first example. All right. So looking at this first one, find the domain of each. The first function that they give us is f of x is equal to x squared minus 7x. So the first thing we want to ask ourselves, is there a value All right, so is there a value that we can plug in for x that will make the equation undefined? You know, can we plug in anything into this equation that will make it undefined? All right, so the answer is no. I can't plug anything in there that will make it undefined. And if you're a little sketchy on what I mean by that, you'll see in the next example. Basically, there's nothing I can plug into this equation for x that won't work. I can plug in 5, I can plug in 0, I can plug in 1, I can plug in negative 100, negative 1 million. I will always get an answer. I can calculate that. I will just square the number and then subtract 7 times that number. There's nothing I can plug in to make it undefined. Since that's the case, the domain is going to be negative infinity to infinity. I can use every value for x. There's nothing I cannot use in this equation. And of course, that will not be the case for every equation that we have, but That is the one for this. So if I had g of x is equal to 2 over x minus 5, so ask ourselves that same question. Excuse me. Yeah. So you're looking at this rational expression, this fraction, and you ask yourself, can you make it undefined? The answer here is yes. So fractions are undefined when the denominator is 0. So since that's the case, I'll set my denominator equal to 0 and solve. All right, x minus 5 equals 0. Add 5 to both sides. 5's cancel. X is equal to 5. Now keep in mind, this is not my solution. This is the value that cannot be used. So remember, if I take that 5, plug it into my denominator, 5 minus 5 will be 0, and I have 0 in my denominator. So this is the value that cannot be used. You want to know when your denominator is equal to 0, and that's when x is equal to 5. So my domain if you were to look at the number line, it's a generic number line. I can't use 5, but I can use everything after it and everything before it. I can get as close to 5 as I would like. I just cannot use 5. So I would go from negative infinity to negative 5, use that parentheses, 5 to infinity. And that would be my domain. Oh, should be, why did I put a negative 5? Sorry about that. Should be negative infinity to 5 and then 5 to infinity. All right, questions before we do another one. All right, g of x, let's go h of x. All right, similar scenario from the last one. Just have more in the denominator. H of x is equal to 3x plus 2 over x squared minus 2x minus 3. Once again, we have a rational expression. We have a fraction, so we're going to set denominator equal to 0. All right. X squared minus 2x minus 3 equal to 0. Use whatever method you like to use in order to solve it. Remember, you can solve by factoring, completing the square, or quadratic formula. We'll go ahead and factor this. So it's x minus 3 times x plus 1. Set each part equal to 0. X equal to 3. X equal to negative 1. Once again, they are not our solutions. Where my green at? Okay. They are values that we cannot use. All right. So now, just like I did before, just to make sure we're okay with the intervals, set up your generic number line and you can see it. All right, so our domain is going from negative infinity to negative 1. Then we have negative 1 to 3, and then 3 to infinity. So those are the values we can use. We cannot use the negative 1 and 3. So don't forget to make sure that you use parentheses, which signifies that we cannot use those values versus using brackets. So if you use the bracket, that means you can use it. The parentheses mean that you cannot use those numbers. Questions before we do at least one more like this? All right, so next one, j of x is equal to the square root of 3x plus 1, 3x plus 12. So here, once again, we're asking ourselves, can I make this expression undefined or you could say when is a radical undefined? So cannot take the square root. And I shouldn't say when is a radical. I should say when is this radical undefined, not a. Cannot take the square root of a negative number. So we cannot take the square root of a negative number. So, all right, got a question. Yes, you can take the square root of 0 because 0 times 0 would be 0. But we cannot take the square root of negative. Good question, because it was about to come up. Once I write this next statement, so how am I going to write this? You want to know when is the radicand. So what's under the radical is the radicand. So let me write that better. So you know when is the radicand less than 0? As a matter of fact, not less than 0, less than or equal to, because I just mentioned that you can let it be equal to 0. And as a matter of fact, you get the less than, let's say greater than. Then we don't have to do anything extra. So when is the radicand greater than or equal to 0? So we'll do 3x plus 12 greater than or equal to 0. So that we know everything that's less than that 0 we cannot use. So we'll set that greater than or equal to 0 and then solve it. So going back to what we had up previous, when you have a rational expression, you always do this: set the denominator equal to 0 and solve it. When you have a radical or a square root, you're always going to set your radicand, what's under the radical, greater than or equal to 0, and then solve that. All right, so subtract 12. Oh, man. All right, so it'll be 3x greater than or equal to negative 12. Divide by 3. 3's cancel. X is greater than or equal to negative 4. All right, so that sets your domain to be negative 4 to infinity. And be careful here, before we use parentheses, this time we're using bracket because we have the or equal to symbol. And we can use the negative 4 because when you plug in negative 4, you get 0. Remember, we just mentioned that you can take the square root of 0. All right, questions. All right, so we'll look at combinations and then call it a day. All right, so algebra functions, basically a combination of your functions. F plus g of x is f of x plus g of x, just a shorthand way of writing it. F minus g of x is f of x minus g of x. F times g of x, f of x times g of x, and then f divided by uh, g of x, f of x over g of x. Like I said, the first way is just a shorthand way of writing it. Bring that down some. All right, so if they give us f of x being to be 2x minus 1, and then g of x to be x squared minus x plus x minus 2, it tells us to find each. All right. They give us f plus g of x. So as I said before, that means f of x plus g of x. So we take f of x, add it to g of x, and combine your like terms. And that's it. All right. Questions before we look at the next one? So if we're doing f minus g of x, same thing except with a subtraction sign. Don't forget, if you have that minus sign in between your quantities, that minus sign has to be distributed to each term that follows. So if you wanted to rewrite it, you could. That would be a negative x squared minus x plus 2. Now we combine our like terms. Negative x squared plus x plus 1. All right, f times g of x. All right, so we multiplying both expressions together. So distribute the 2x cubed plus 2x squared minus 4x. Distribute the negative 1. Negative x squared, negative x plus 2. Combine your like terms. All right, so it's 2x cubed plus x squared minus 5x plus 2. Last one. F of x over g of x. F of x is 2x minus 1. G of x is x squared. And then over there, x squared plus x minus 2. If you could factor or reduce, then you are expected to do so. But there's nothing that we can do there with that. Can't reduce or anything. So that would be the answer. Also, if this wasn't in there, but you may see something like this. If I had f of g of 2, that just means you will plug in 2 where you see x. Now you can either plug in 2 right here and find of them, each one of them individually, or you can plug in 2 here. It'll be the same thing. So I just plug in 2 where I see x. So there's 4 minus 1 on top. 4 plus 2 minus 2. That'd be 3 on top. 4 plus 2 is 6, minus 2 is 4. So if they put a number in there, that just means you plug in that number where you see x. Questions? Any questions? All right, got 7 minutes. I'm not gonna rush and try to close out 2.6. So we'll pick up right here on next class. Any questions before we close out? Like I said, we'll pick up right here on next class. Go from there. All right, so everybody's good? Everybody's straight? All right. So if you guys are good, I'm good. Don't forget to shoot me that email if you need help or assistance. Outside of that, videos will be posted shortly as well. And I will see you guys next class.